Hello guys and welcome back. Now we're going to take a look at creating a more complex attraction effect where we can have any random particles and have them attract and match a specific silhouette or specific geometry. Now this can be very challenging, especially if we have random geometry or the source is very different from the goal. There's no way to map the particle, and I have a very simple workflow for doing any kinds of transitions or attraction between any kinds of geometry you may have, even if a moving target or anything like that. And the idea is, let's say we want to create a grid. Let's see, let me move this. So this grid, and we want to emit points from this grid and have them attract and form the shape of this guy. Okay, well, it's going to be very tricky because it's hard for us to tell the point which location it needs to sit on, so it doesn't overlap with other points. But if we do this, if we take this geometry, the grid, and scatter 1,000 points on it. Okay, each one of these guys have a number. Then we go to this guy and scatter 10,000. There is 10%, 1,000% that each point will find a goal here, because here we have 1,000 and here we have 10,000. But how do we tell this point which point to look for? Well, very easy. These guys have a point number. These guys have a point number. Let me see. So these guys have a point number as well as this. They both have shared numbers. Okay, this is 1,000 points and this is 10,000 points. So I'm pretty sure those 1,000 will find their correspondent here by just using the ID. So what we're going to do is we're going to create a point VOP. I'll show you another way of accessing the data. I'm going to connect this, and let's say we have a particle sim that it did emit these points. This is the result from the particle sim, and this is our geometry goal. I'm going to scatter points on it, and I'm going to connect them here. And if we can get these particles in the sub-level to snap to that surface nicely, we can do the same thing in pops. So what I'm going to do is I'm going to use a point attribute, and this is the same as doing the point expression in attribute wrangle. I'm going to say second input, and what I want to import is the point number of the same point number. Okay, so this is going to give me back the point number of the second input. If I connect this, see, they all snapped there because they were successful at finding a location. So let's mix between this and this guy, and if we do that, we get a nice blend shape. So if we compute a vector from this position, from the current position to the next position, we can create a velocity vector that we can use as a force to move the point from point A to point B. Let's see how to do that in subs, in particles. Let's create a pop network. This is my emission. This is my goal. Okay, and I'm gonna lower this to 100. Let's say 1,000, and I'm going to increase this to 100,000. I turned off relaxation so it's faster. Let's increase this even more. I'm going to dive inside. I'm going to say all points, and I'm going to give them a velocity pointing upward, and let's hit play. Cool. And I want to create this this vector, so I'm going to create an attribute, pop wrangle. I'm going to connect that. Sorry, not pop wrangle, pop VOP. I'm going to connect that, And we're going to do the same thing, import point attribute. The point attribute is going to be from the second input, and the point number is going to be this. And I'm going to create a velocity vector by subtracting the current position from its goal and plug that into the velocity. Let's go back up. This guy here, this node, we need to set its input. So first input, first context, second context, third context, fourth context. So that this guy, when we do this, it brings the correct input. You can also do it here, second input. And now we're streaming in these guys. Let's hit play. It's inversed, so let's negate the force or revert the subtraction. Let's hit play. And every point, every time it gets emitted, it's gonna do this. Okay? Let's do some more stuff. I'm gonna change the emission. And I'm not gonna change the emission. Let's leave it at this. And I'm going to use the height. Right now, if I disable this, the points are gonna go up in space. So I want to take the height and remap it. Let's dive inside. Let's enable this back in. Turn this off. And let's take the height of this guy. So velocity Y, position Y. And I'm gonna plug that into the color. I'm gonna use a fit range and say, try to get a nice ramp. So the particle goes from 0 to 10. And I want the ramp to be inversed. Sorry, it's correct. So 10.4 and -2. Okay, something like that. And I want to use this ramp here as a multiplier. As the point goes up, the more I want this velocity to affect it. So I'm going to use a mix like we did before. I'm going to mix between the current velocity and the new velocity using this guy, using this mask. Let's turn off the color and let's give them a unique color. So pop color, and I'm going to say ramp, and the ramp, we'll set it to, let's just give them a random color, constant color, sorry, something like that. Let's hit play. As they reach that part, they're gonna get attracted to this, which is very, very cool. I'm not sure why it's sliding here, so we'll add a pop drag. I think I know why, because this could result in negative values, maybe. Let's clamp this between 0 and 1, so if there is a value less or higher than these, it will get removed. Let's drag this here. Cool. And what we can do also, we can use the length of the velocity vector, this new velocity, as a multiplier. So it's 1 here, and as the point gets closer, we can either multiply it or reduce it down. So let's compute the length of that, use a fit range, say between 0 and 10, and let's use that as a multiplier to the velocity. Let's see how that looks. Cool. So as it gets closer, it slows down, and we can invert this as well. We can give it a 0.1 value, just a tiny bit. As it gets closer, it's going to get faster. It should get faster. Or it gets even slower. Not sure. You can always visualize this if we're having a hard time seeing the values. We can plug it into the color and turn this off. And we should be able to see the values. I'm not sure. So let's see. Yeah, I need to figure out the length, but I'm sure you guys can do this. it's working. Yeah, so as it gets closer, it's gonna get stronger and stronger. And we can do this. We can stop the emission after frame 20. And they should all find their corresponding position and stop. Change this to 400. So if you have any kinds of particle sim, you can do this effect with. Okay, this bottom part, I'm not sure why it's doing that. Maybe because the mask of the height. I didn't run into that before. So let's say instead of a grid, which is simple, let's create a toy and move it to somewhere the same location. Let's put down a transform node. Something like that. And let's create a mask. Point bulb. Noise. Or we can do this in the color. Let's go up and let's add this here. And let's increase the number of points, increase the noise so we can clearly see it, increase the frequency, and let's expose the offset. And then I'm gonna use a blast node to delete any point that is black. If the c.x is less than 0.2, delete the points. And only left with that. And then I'm going to use the $F to animate the offset so the noise changes over time. Say 20, something like that, and let's give it. Yep. So now we have particles traveling. And let's remove this this mix, or set it to, we can animate it or directly override it. I don't want the emission, the height thing. Now we have some cool emission happening and some attraction between two random geometries. And again, you can do this with anything you want. Now, one thing that you may want is to fill this volume, to have the particles fill in the volume instead of just the surface, and this requires volume, and it's something that we're going to be looking at next week. So we can take this geometry and create something called, and use a node called VDB from Polygon to create a VDB volume. I'm gonna change this to density and increase the voxel size so it's not too dense. Let's lower this to 0.1. And then we can use this node to scatter the points instead. Let's increase this to 100,000 and this more as well. And let's do the same thing here as well for the toy. So they are both volumetrics, not just points in space on the surface. Let's turn off relaxation. We have the noise, all good. Let's hit play. and it will get there. And now it's filling the entire volume, not just the surface. And the more points you add, the more you're going to be able to describe the surface. Cool. I think that's pretty much it for this week. Thank you guys for watching, and see you in the next video. Bye bye.